everyone and welcome back to IB Spectrum. Today, we will be exploring exothermic and endothermic reactions. In this video, we will be focusing on criteria A, B, and C. You can turn on the captions to make sure you don't miss out on any information. In every chemical bond, different chemicals store different amounts of energy. For example, in the equation shown below, each of the different molecules will hold a different amount of energy. As we can see here, oxygen and carbon dioxide would hold different amounts of energy. In every exothermic and endothermic reaction, there are two parts, the system and its surroundings. The system is the area of interest and it has a boundary. Everything else in the universe is its surrounding. Using the example reaction shown below, the place where this combustion is taking place would be the system, while the rest of the space would be its surrounding. In these reactions, you either release energy to the surroundings or you take in energy from the surroundings. Depending on this, we determine whether these reactions are exothermic or endothermic. Exothermic reactions are reactions which result in the transfer of energy from a system to its surroundings. Heat is given off or produced. Bonds in the product are stronger than the bonds in the reactants. In exothermic reactions, the products have less energy or heat content than the reactants, and this reflects in the energy profile diagram. The enthalpy is negative. Enthalpy is nothing but the sum of internal energy and the product of its pressure and volume, and is represented by the symbol delta H. Now, I just mentioned an energy profile diagram, but what exactly is that? An energy profile diagram is a representation of how the energy of a chemical changes during its reaction. Shown below is a sample energy profile diagram. As we can see, the x-axis is represented by the extent of the reaction, while the y-axis is the energy in kilojoules per mole. In the diagram, the reactants, the product, the enthalpy, and the activation energy, which is the minimum amount of energy needed for the reaction to occur, are included. These factors can help us identify whether the reaction is exothermic or endothermic. In the following diagram, we can see that the product has less energy than the reactants, and that shows that energy is being released into the reactant surroundings. We can also see that the enthalpy is negative, which means that there is a decrease in the energy content of the system, hence signifying an exothermic reaction. Now moving on to the experiment, an example of a common exothermic reaction would be reacting sodium hydroxide pellets and water. Initially in this reaction, the beaker in which these chemicals are kept in is at room temperature, and then the beaker turns hot because it releases energy into the surrounding environment. Burning of wood also releases energy and can be classified as an exothermic reaction. Now moving on to the other type of reaction, endothermic reactions. Endothermic reactions are reactions which result in the transfer of energy from surroundings to a system. Heat is absorbed. Bonds in the product are weaker than the bonds in the reactants. In endothermic reactions, the products have more energy or heat content than the reactants, and this reflects in the energy profile diagram. The enthalpy is positive because there is an overall increase in the energy of the system. The energy profile diagram for endothermic reactions will be the complete opposite of exothermic, and the energy levels are different for the reactants and products, hence changing the activation energies and enthalpy. In the diagram, we can see that the product has more energy than the reactant, signifying an endothermic reaction. Now moving on to the experiment, an example of a common endothermic reaction is a reaction between barium hydroxide and ammonium chloride. Initially, the beaker is at room temperature, and then it turns cold as it absorbs energy from the environment. Photosynthesis also absorbs energy and can be classified as an endothermic reaction. Exothermic and endothermic reactions are an important part of IB/MYP chemistry as they explain the nature of different chemical reactions and how they affect their surroundings. Thank you so much for watching this video, and I hope you were able to understand this concept. Make sure to like, subscribe, and check out our other videos that cover IB/MYP 4 and 5 syllabus for all subjects. Also, make sure to check out our Instagram page. The link is provided in the description. Thank you.